In this video, we are looking at solving equations. Now, I'm going to do solving equations over two videos. I'm going to do one video, this one, on the more simple examples, and then the next video is going to be on the harder examples. Solving equations are the fundamentals of algebra. If you can understand how to solve equations, this is something you will use throughout algebra as a whole, not just within this one small topic. Okay, so let's look at the first equation here. Now, this is very simple. You will probably look at this straight away and think, well, x is simply just 1. The way I want you to think of these questions as I'm going through them is think of them as a function machine. What I mean by that is we start off with our x as our input, and as we go through the machine, we are adding, subtracting, dividing, multiplying things to get to our final output. Because when it comes to solving them, you do the exact opposite as what you did when you put them in. So when we want to work them out, we start with our 3 and we do the opposite as we go back down. So rather than adding 2, we're going to subtract 2. And this will eventually take us back to our original answer where we can work out what x actually is. 3 take away 2 leaves us with 1, which is what we actually knew it was just by looking at it. So that's one method to work it out. You could also look at this in a slightly different way. So once you get more confident with it, ultimately we want to have our answer as x equals something. Now, to get that, you can see that the difference between these two lines here is that we have a plus 2 on the first line. Similarly to how we did it with the function machine, we want to simply subtract 2 on both sides to remove that 2, leaving just the x on the left-hand side. And in doing that, this will cancel with the plus 2 on the left-hand side and subtract 2 from the right-hand side, leaving us with x equals 1. So those are the two methods that we will do. This is the one I think is really beneficial. It's a visual representation of exactly what's going on. And for those of you that find algebra a little bit easier, you may be able to find this one more straightforward. So, question number 2. 2x plus 4 equals 10. Now again, I want you to imagine that function machine. It will take some practice to work out what is going on in the function machine in the right order, because it does make a difference. If you want, pause the video, give it a go yourself, try and draw out this function machine just like we did before for this question, and see if you can get the same answer as me. So in this one, we're starting off with that x. We're multiplying that by 2. We add 4. And our final result is 10. Simple as that. So to work it out, we start with that 10. We're subtracting 4. Rather than timesing by 2, we want to divide by 2. And that will give us our x. So 10 subtract 4 is 6. Divide that by 2. And that will give us 3. And that is simply our final answer. So x equals 3. Just like we did with the first one. If we put our function machine over here. Okay, so doing it the other method, I like to think of it as we want to get rid of everything that isn't attached to the x first. So you can see here the 2 is what I like to call attached to the x. So we do that one last. The plus 4, on the other hand, is not attached to the x, so we can get rid of that one first. So if we subtract 4 from both sides, again doing the opposite of what the 4 is actually doing, because this will cancel it from the left-hand side. This will leave us with 2x equals 6. Again, just like this first step we did over here. Now we are only left with 2x, and eventually, remember, we want x. So to get there, we've got 2 multiplied by x at the moment. To counteract that, we want to divide that by 2, and that is going to leave us with x equals 3. So these are the two methods you can do. I will continue to do them both because I find them really useful. Okay, moving on to question 3. 5x minus 3 equals 17. Again, very similar, we just have a negative this time. So we start off with that x. We're multiplying by 5. We're subtracting 3. And finally we're left with 17. So doing that in reverse, we add 3 and we divide by 5. And that gives us the x. So 17 add 3 gives us 20. Divide that by 5 is 4. So x equals 4. Again, if you want to show that in a good exam technique, we want to add 3 first to both sides because this will remove this 3 here, leaving us with 5x equals 20. And because it's 5 multiplied by x, we want to divide by 5 instead. So x equals 4. Just like that, we get the same answer both times. Okay, moving on to some division ones this time. So x over 3 plus 6. You can see here, these two examples both use division. Because of the way they are written, it changes the order of how we do it. So, you can see here, the x has been divided by 3 first, and then we add 6. So using that information, pause the video, try and work out what the function machine would look like first. So we start with x, we divide by 3, we add 6, and that equals 13. Now doing that in reverse, we start with 13, we subtract 6, we multiply by 3, and that will give us our final answer. So 13 take away 6 is 7, multiplied by 3, our x must be 21. Again, doing that in a different way, the x is attached to the 3 in this case, as I like to say before. The plus 6 is separate, so we can do the opposite of that first. We subtract by 6 on both sides, leaving us with x over 3 equals 7. And because it's x divided by 3, to do the opposite of that, we want to multiply by 3, just like we spoke about before. So x equals 21. Okay, and finally, our last example. Our function machine would look slightly different for this one. We've got x. That x gets multiplied by 2, because you can see the 2 is attached to the x, so that must have come first. We then subtracted by 2, and we then divided all that by 4 to give us 2. So working in reverse, we multiply by 4, we want to add 2 rather than subtract 2, and we want to divide by 2 finally, and that will give us our x. So 2 multiplied by 4 is 8, add 2 is 10, divide that finally by 2, and our final answer will be 5. Again, doing this the other method, we can see that the last thing that happened, because the whole function is being divided by 4, we want to multiply by 4 to oppose this first. This will give us 2x minus 2 equals 8. Next, we can see that the 2 is attached to the x here, so we want to sort out the subtract 2 first, or the take away 2, by adding 2. This will leave us with 2x on the left-hand side and 10 on the right-hand side. Finally, we have 2 multiplied by x, so to do the opposite of this, it's divide by 2, leaving us with x equals 5. And that's exactly what we did in the function machine example. Now this has covered most of the foundational content that you need to solve equations. In the next one we will discuss what to do when we've got x's on both sides, when brackets get involved and other things like that. So I hope that helped, and thank you very much for watching.